Hello Year 12 further mathematicians. Just going to continue with the complex numbers chapter in the Core Pure 1 book. Just the second half of 1.1, so I'm going to call it 1.1.5, imaginary numbers and complex numbers. I'm going to go back to a single maths concept, which is a quadratic equation which looks like ax squared plus bx plus c is equal to 0, and you were taught 3 different cases would happen. If I looked at the discriminant and it was greater than 0, you would say, or you'd be expected to know, there are 2 distinct real roots, and if the discriminant was equal to 0, you'd have a repeated real root. And then thirdly, if the discriminant was less than 0, you would say no real roots. And that is still completely true, obviously. However, we just edit the last sentence in further maths. So rather than no real roots, we say instead 2 complex roots. In other words, we can have imaginary numbers in there. So there are answers, it's just we can't point to them on a number line. The concept of a complex number and what it is on a number line, you'll find out in future sub-chapters, but your standard number line going from minus infinity to infinity, the complex numbers don't belong on there, they belong somewhere else. But yeah, 2 complex numbers instead of no real roots. So if I was asked to solve an equation which looks like this, z squared plus 9 is equal to 0. Firstly, the use of the letter z suggests that I'm dealing with complex numbers. So normally when I've got an equation with just the letter x in there, I don't have to consider complex numbers and I use single maths stuff. But now I have the letter z, that reminds me, oh yes, complex numbers is a thing, and I can use I, etc. So z squared plus 9 is equal to 0. Solve the equation using the same techniques as before. Make z the subject. Square root, you get 2 answers. Rather than saying math error though, you say it's the same as plus or minus root 9 times root negative 1, which is plus or minus 3i. Or if you prefer, 0 plus or minus 3i. But yeah, that is a complex number or an imaginary number, and that does make sense. Now there is a complex mode on your calculator which you can make use of, and even if you solve the equation, the quadratic, it would give you the complex roots anyway, but it's good to just do this algebraically without using a calculator for today. Second example is another quadratic equation, but this one is a more complicated version, where if we try to use factorizing, it wouldn't work, which would mean we've got 2 choices. We either use the formula or we use completing the square. Good news is both methods work when finding the complex answers. So let's do the single maths attempt, which would be a formula. So the formula would be minus b plus or minus the square root of b squared minus 4ac all over 2a, which would be minus 6 plus or minus the square root of 36 subtract 100 is negative 64 over 2, which is the same as minus 6 plus or minus the square root of positive 64 times negative 1 over 2, which is negative 6 plus or minus 8i over 2. And the shortest way to write that is minus 3 plus or minus 4i. Okay, the alternative is using completing the square, the method I would choose. So completing the square, you rewrite the first two terms as a z plus 3 squared, but then that would produce an unwanted 9, which you subtract. Then you take the number to the right hand side, so that would be negative 16. Then you square root both sides to get plus or minus root negative 16, which you can now evaluate. It is plus or minus root 16 times root negative 1, which is plus or minus 4i, and if you make z the subject, you get minus 3 plus or minus 4i as expected, or both answers match up. So either I've done it wrong twice and coincidentally came up with the same answer, or they are both right. Now the questions I'd like you to complete are on page 7. By page I mean the PDF page, not necessarily the page of the textbook. Exercise 1b, and do questions 1 to 4, but just do the odd parts, and then do question 6, 1 to 4 odd parts plus question 6, and that's it.